Let's learn about gaming mice.
Yay.
We're going to look at DPI, polling rates, liftoff distance, and asymmetrical cutoff, and finally the construction of the mouse, specifically the switches. DPI is dots per inch. Having higher DPI is kind of like having higher resolution. Some common DPIs are 800 and 1600. DPI is also going to be in direct relation with your screen resolution. Higher DPIs will match better with higher resolutions. A higher DPI is going to feel like a higher sensitivity in-game. Gaming mice have been going off the charts with DPI, and if you turn them all the way up like mine, that goes to 26,000, it looks something like this. Watch this. You can find mouse sensitivity converters and calculators online. Those calculations are known as eDPI, or effective dots per inch. Pretty simple calculation. As you can see, 800 DPI with an in-game sense of 1 is an eDPI of 800. With a DPI of 1600 and an in-game sense of 0.5, your eDPI is also 800. Based on your screen resolution and your in-game sensitivity, you can find an eDPI that works best for you. It's common to match 800 DPI with 1080p monitors and 1600 DPI with anything 1440 or above. Next, we're going to talk about polling rates. So polling rates are going to measure how often the signal is sent from the mouse to the PC in this case. And it's going to be measured in hertz. And in this case, of course, higher is better. So a polling rate of 1000 hertz will send the signal 1000 times per second to the PC. Polling rate is also connected to your monitor refresh rate. A higher polling rate will give you more inputs per frame. Polling rates in DPI are connected in a similar way, which is called saturation. Having a higher DPI matched with a higher polling rate will give you more inputs for every dot that the mouse is reading. Next, let's look at lift-off distance. That's the height at which the mouse sensor stops tracking the surface it's on. So we're going to look at liftoff distance and something called asymmetrical cutoff. So asymmetrical cutoff means that your mouse will stop sending an input at a certain height and start reading at maybe a slightly higher distance, so that when you lift off, it will stop reading, and as you put it back down, it will begin to read from a further distance, so that you're getting input sooner when you put the mouse back down. My liftoff distance is set to 1 millimeter. So lastly, we're going to look at optical versus mechanical mouse switches. Mechanical mouse switches use a mechanical mechanism to complete a circuit, whereas optical mouse switches will use a similar internal build, but instead of making contact with another surface, it's going to interrupt a beam of light. Having this one extra part here will potentially cause more wear and tear between the surfaces, and the optical is light speed, so it's going to give you faster input. There's also something called debounce delay, which you can adjust for optical mouses as well, and that refers to the time between when these contacts take place. I've been enjoying the optical switches on my mouse, but mechanical switches are just fine as well. Alright, we learned about DPI, polling rates, liftoff distance and asymmetrical cutoff, and the switches. So that's everything for this video. We could talk about mouse pads, and we can talk more about mice in the future, but let me know what kind of mouse you use in the comments.